Hello and welcome. Here's a quick video reviewing how to write a dissociation equation. Now, a dissociation equation is when you show what happens to a substance when you place it in water. So what you want to do is first of all identify your compound. Aluminum sulfate is an ionic compound. Now, when we write a dissociation equation, we are going to show the formula for the compound before it's in water. Ionic compounds before they're in water always start as a solid compound. Now I check my solubility chart. When I check my solubility chart, aluminum sulfate is soluble, so it's going to dissociate, split apart into the two ions that make up the compound, aluminum ions and sulfate ions, okay? The number of ions is based on the subscript there. I have two aluminum ions. I show them as ions by writing their ion charge superscript, and they are now dissolved in water, so they are aqueous, and I have three sulfate ions. Sulfate ions have a charge of 2 negative, and again, they are aqueous. So when they are ionic and soluble, they dissociate into ions. The next compound I have is a molecular compound. Molecular compounds can be solid, liquid, or gas. So the question will usually tell you the state, but it's a hydrogen compound, and hydrogen compounds in water become acids, and so they act like they are ionic. So this starts as a gas. It is going to do what ionic compounds do, but we call it ionize. So it's still splitting into free ions, 2 hydrogen ions, and 1 sulfide ion. Okay, so again, we show them as ions. These two compounds will be conductive in solution because they make free ions. Next, we have ionic compound silver chloride. Silver chloride, again, because it's ionic, starts as a solid, but when we check the solubility chart, it is insoluble. So what happens with an insoluble compound? Nothing. It stays the exact same as it started. And last, we have molecular compound, glucose. Now, there is no solubility chart for molecular compounds, so to know whether or not it's soluble, the question usually has to tell you, but a hint, all common molecular compounds are soluble. So this is molecular and soluble. What do I do with a molecular soluble compound? I do not split it apart. It stays a whole molecule. The only thing that changes is the state, so it's changing from its original solid to aqueous. Thank you for watching.